In section 6.4, we study the graphs of sine and cosine. In particular, we'll look at amplitude and period of these graphs. PreCalculus Online starts now. Section 6.4, Graphs of Sine and Cosine. So take out your unit circle and let's examine the y-coordinates at the various angles. We have a table of values we want to fill out. We're not using every angle here, we're just going to use some of them. And let's go ahead and fill out the table of values. So the sine of 0 is 0. The sine of pi over 6 is 1/2. The sine of pi over 3 is root 3 over 2. And when we go to graph this, root 3 over 2 is approximately 0.866. The sine of pi over 2 is 1. The sine of 2 pi over 3 is root 3 over 2. The sine of 5 pi over 6 is 1/2. And the sine of pi is 0. And that's the upper half of the unit circle. Let's do the bottom half. The sine of 7 pi over 6 is negative 1/2. The sine of 4 pi over 3 is negative root 3 over 2. The sine of 3 pi over 2 is negative 1. The sine of 5 pi over 3 is negative root 3 over 2. The sine of 11 pi over 6 is negative 1/2. And then we're back to 2 pi. The sine of 2 pi is 0. Now, as we learned in the last lecture, this is one period of the sine function. So by mapping out these values and creating the curve, we create all of what the sine function can possibly do. And then everything else is just repetition of that through multiple periods. So let's go ahead and graph these points. And graph it in purple maybe. So 0, 0. Pi over 6, comma 1/2, so that's halfway up the grid here. Pi over 3, comma root 3 over 2. Root 3 over 2 is about 0.866, so we're just going to put that right about there. Pi over 2, comma 1, and then we start repeating some values. So I'm just going to go ahead and fill in these points. And then create the sine curve, smooth. And there it is. And that's one period of the sine curve. It's your basic shape. It goes up and then it goes down. It has a maximum of 1, it has a minimum of -1. And it hits 0 3 times from start to end if you count the ends twice there. Let's look at two characteristics of sinusoidal functions known as amplitude and period. So here we go. If omega, which is like a little curly W, is greater than 0, then the amplitude and period of y equals a sine of omega x, or y equals a cosine of omega x, are amplitude is equal to the absolute value of the a, and the period is represented by a capital T, and that is equal to 2 pi divided by omega. So from college algebra, you can think of the omega as the number that affects the horizontal stretch. In sinusoidal equations, we just call this horizontal stretch value altering piece the period. All right. So let's take a look at example 1. Graph y equals 3 sine of x. So first off, the amplitude is the absolute value of the number in front, because amplitude has to be positive. So that's just 3, no problems there. The period is 2 pi divided by the number in front of the x. Well, there is just the imaginary 1 there, so it's just going to be 2 pi over 1, which is just 2 pi, the standard period of sine. So to graph this, we know that the sine function starts at 0, and at pi over 2, it's going to reach the 3, because it should have, a normal sine function only goes up to 1, but because of the amplitude serving as a vertical stretch, it stretches it up to 3. Then at pi, the sine of pi is 0. The sine of 3 pi over 2 is, again, negative 1, but because of the amplitude change, it stretches it out down to negative 3. And then the sine of 2 pi is 0. Let's go ahead and fill in the back side as well. We know that this curve is going to go down as we go backwards here. So it's going to go down to negative 3, and then at negative pi it goes back up to 0. It has to follow the same repeating pattern over and over. And there it goes. Put some arrows on the ends here. And that's pretty close. Maybe this piece could be a little bit better. There we go. All right, let's look at example 2. Graph y equals sine of 4x. So the amplitude is the number in front, absolute value of that, so that's a 1. And the period is 2 pi divided by omega. And omega in this problem is 4. So that means the period is going to be pi over 2. That means the sine function has to hit all of its points just in the interval on the x-axis between 0 and pi over 2. So to do that, let's start at 0, 0. Sine function always starts at 0, 0. And then I can sort of map out how far the period is going to be. Well, it's going to be over pi over 2 from 0. So it's just going to cover from 0 to pi over 2. That means I have to cover the entire sine curve in that interval. So I know it's going to end at pi over 2 with another point at 0. We also know that the middle point of the sine curve is another 0. So we can plot that. And we know that halfway between the first 0 and the middle 0 is where the function reaches its maximum. So that's going to be at 1. So this is going to be the maximum right here. We also know that halfway between the middle 0 and the ending of the period, that's where the function reaches its minimum. So it's going to be at negative 1. And then here is one whole period of the sine curve. And now we just have to repeat that pattern throughout the rest of the curve, the rest of the graph that's given. So max, 0, min, 0, max, 0, min, 0, max, 0, min, 0, and then going backwards, the same thing. And then connect this as best you can. Something like that. So recapping, we discovered what the period was, and then we plotted the 4 main points in order to get that one period, and then we just repeated the period throughout the graph. Let's take a look at the graph of cosine. So the graph of cosine starts at its maximum, starts at 1. And then it has the values, root 3 over 2, 1/2. Then at pi over 2, it reaches a 0. And then it goes down to negative 1/2, negative root 3 over 2, negative 1, so it reaches its minimum at pi. And then it starts to rebound and go back up again. It's another 0. Then it continues on, positive 1/2, positive root 3 over 2, and it ends where it began at another maximum. Well, that's pretty good. All right, so there's your cosine curve. Let's look at example 3. Graph y equals 4 cosine of x. So the amplitude is equal to 4, and the period is unaltered. It's still just 2 pi. So to graph this one, we start at 0 and the max. So there's the max. Again, this is a cosine curve, so we start at the max. And then after pi over 2, it goes to 0. And then at pi, it goes down to the minimum, negative 4. At 3 pi over 2, it goes to 0 again. And at 2 pi, it goes to the maximum, 4. Continue the pattern going backwards on the left. So we have a 0 at negative pi over 2 and a minimum at negative pi. Connect this like a sinusoid. And there's your cosine curve. Let's look at example number 4. Graph y equals negative 2 cosine of 3x. So here we have the amplitude is equal to the absolute value of negative 2, which is 2. We have a period that's going to be 2 pi over 3, but we also have this negative in front. And the negative in front is going to be a reflection over the x-axis. For cosine, that means instead of starting at the maximum value, we'll start at the minimum value. So let's go ahead and plot that. So instead of starting at 2, we're going to start down here at negative 2. But then after that, the pattern goes on just like normal, and we're just sort of starting in a different place. Let's consider now the period. The period is 2 pi over 3, which is this number here. And to see that, count off by pi over 6's. 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. So each of these represents a pi over 6. And to get the period of 2 pi over 3, that's the same as 4 pi over 6. So we know that after one period, the cosine function is going to return to where it started at 0, which was the minimum of negative 2. We also know that halfway between the period is where the cosine function is going to reach its maximum. And then halfway between that is where the cosine function is going to be a 0. Same thing on the other side, halfway between that second half is where it's a 0. So the first period looks like this. There it is. And then we can repeat that going forward with 0, max, 0, min, 0, max, 0, min. Same thing going backwards. 0, max, 0, min, 0, max. And then connect the dots. And there you go. Example 5. Graph y equals 7 sine of 2x using the key points. Identify the maximum and the minimum. Find the domain and the range of the function. So in this case, we're just going to graph it freehand without the grid. Let's identify the amplitude. Amplitude is 7. The period is 2 pi over 2, which is pi. And for these, we want to always graph 2 periods. 2 periods. So I'm going to start with, it's a sine function, so I'm going to start with 0. And then let me figure out where this needs to go. The period is pi, so that means after an interval of pi, I need to be back at 0 because it's a sine curve. I know that halfway between 0 and pi is another 0, so that's going to be at pi over 2. And then I know that halfway between 0 and pi over 2, this half of the first half, is where it's going to reach its maximum, which is going to be 7. And then halfway between pi over 2 and pi is where it's going to reach the minimum of negative 7. And then let's repeat that going forward. So figure out these numbers. Remember that this is just an interval of pi here on the left, and then another interval of pi on the right, going to the right. This is one period. And this is another period. And then you can figure out the numbers on the axis by using some fraction addition and things like that. Fill in the max, the 0, the min, and the last 0, and connect the dots to form a sinusoidal. And there's 2 periods of the sine curve. Maximum is equal to 7. Minimum is equal to negative 7. The domain of the function is the set of all real numbers, and the range is the set of numbers from negative 7 to 7, including the endpoints. Example 6, graph y equals 3 times cosine of 6x. Using the key points, identify the max and the min. So, as always, we find the amplitude is 3. The period is 2 pi divided by 6, which is pi over 3. And let's set up the grid here. So the sine curve, the cosine curve starts at the maximum, so that's going to be 3. And then there's going to be 4 tick marks in the middle. until it returns to 3. And it returns to 3 at pi over 3, because that's the period of the cosine curve. Halfway between the two maxes is where it reaches its minimum of -3. And then halfway between those two delineation points is where it reaches the 0. And let me extend the line here a little bit. All right. 1, 2, 3, 4. Going out another period would be 2 pi over 3. And the number between pi over 3 and 2 pi over 3 is pi over 2. And then I can continue the cosine curve. A 0, a minimum, a 0, and a maximum. And then connect the curve, connect the dots in the cosine curve. Like so. The maximum value is 3. The minimum value is -3. Let's look at example 7. Graph y equals -8 sine of pi over 2 times x. So first, the amplitude is going to be equal to 8, and the period is going to be equal to 2 pi divided by omega, which is pi over 2. In this case, the pi's cancel, and the 2 on the bottom flips up to the top to give us 4. And then finally, we also have a reflection over the x-axis from the negative in front. Now, one word on this pi that's in the equation itself. A lot of times, if the x numbers that you're using for the x-axis need to be regular integers or regular fractions without the pi, then the pi goes in the formula, and then you can see that you end up with just a regular type integer here. This would be appropriate for things where the x represents time or something like that. So let's go ahead and graph this. It's the sine curve, but it's reflected. So it's still going to start at 0, and then let's mark off the 4 key parts to a period. But in this case, the period is 4, so actually each of these are just integers, 1, 2, 3, and 4. The sine curve should go up to the maximum, but because of the reflection, it starts by going down to the minimum. Then it comes up to the 0, then to the maximum, and then back down to the 0. 1, 2, 3, 4 more. 5, 6, 7. And repeat. And connect the curve. Let's take a look at example 8. Find the equation of the sine function graphed below. So we know it's going to be a sine curve. Let's identify the maximum. The maximum is at 3. The minimum is at -3. And the distance from the middle line to the max, or from the middle line to the min, is what the amplitude actually is. So in order to find the amplitude, it's the distance from the middle to the maximum or to the minimum. So we know that the amplitude is going to equal 3. Next, what is the period? Well, we need to trace out one cycle of the sine curve, and one period occurs over a distance of pi. So t is equal to pi. Now, in order to find the omega, we just set this up as an equation. 2 pi over omega is equal to pi. and then I can cross multiply and actually just switch the position of these two. It's really quite handy. And get omega is equal to 2 pi over pi, which is equal to 2. And we haven't studied vertical shifts yet, so we won't do any of that here. And we'll just write down the answer as y is equal to 3 sine of 2x. And that's the equation of the sinusoidal.